Okay, so due to the technical difficulties we had during Azure Bootcamp, I wanted to put together the full demo that we would have had about using the Azure functions with the enterprise library. So to start with, I'm going to go ahead and mention that to go along with the demo, you need to have Visual Studio 2017 installed, and along with that, you'll need the Azure Functions and Web Job tools, an Azure subscription, and optionally the Enterprise Library configuration editor, which we'll be using, but is not a requirement to make this work. So with that said, I'm going to go ahead and create a new Azure Functions project. Just going to give it a name here, function demo intlib. Go ahead and create that. And as it creates, I'm just going to note that we will need to rename the function once it gets created. So we're going to use the Azure Functions version 2, which is currently in preview, and that runs on the .NET Core instead of the full framework. If you want to be able to do this functionality in version 1 functions, that is available on the Phidiax blog already as well. But the V2 does give performance enhancements along with some other things, being that it's running in .NET Core instead of the full framework. I'm going to go ahead and pick HTTP trigger, and we'll use the storage emulator since we'll do some testing locally. Click OK to get that project creating for us. All right, we have the project complete. I'm going to go ahead and rename our function here, something a little bit more useful. And that will rename the class as well, but it will not rename the function name. So we just need to manually change that to match. So this gives us our basic hello world style function, which basically returns hello with the name that's passed either on the query string or in the JSON body. So obviously we're gonna make this a little bit more functional than that. So I'm gonna go ahead first to get us started, and I'm gonna go ahead and add in some NuGet references. The first piece we're gonna do is the validation block. So I'm gonna go ahead and add in the validation block. Now this is the .NET Core. So this is the unofficial release. This is not the official enterprise library release. So I'm going to go ahead and pull in that from NuGet. Give that a second to download, along with all of the requirements to go with it. Okay, we're installed. So now we're able to begin testing with the validation. So I'm going to go ahead and pull in just a class that we're going to do the validation against that we would expect our inputs to be. All right, so as you can see, these are pretty simple classes. We've got just a name, a value, and an instance of the separate class, along with a couple of Booleans that we can use to easily test the exception handling framework once we get to that. So now we're going to go ahead and change this to a strongly typed object. We're going to deserialize the body into that test class. And the rest of this here we will be replacing with our additional logic to validate. So before we do any logic to validate, I'm actually going to go ahead and create the validation configuration. So I'm just going to name this validation.config. And then I'm going to go ahead and use the enterprise library configuration tool to populate that with our validation information. So I'm going to go ahead and add in that validation block. And then one thing to note, this configuration utility, if you do plan on using it, does not support loading up types from .NET Core libraries. So what I have here is a stand-in library with the same names and namespaces that I can use to add the validated types automatically through the front end. Just be aware that if you do something like this, you will have to either have a separate build that is in the standard .NET framework, or you'll need to have some stand-in types that you can use because it will not load .NET Core and .NET Standard. So that's kind of one of the workarounds you'll have to do if you're using this configuration tool. So I already have set up on the desktop, like I said, a matching library with basically the same namespaces but is all .NET, so I can easily pull in these types here in the configuration tool. So I'm going to go ahead and pull in those two types here, the outer and inner class basically. Now the validations are set up within rule sets. You can have multiples of those, and the point of that would be, for example, if you had the service where you're creating objects and then a service where you're editing objects, they may require different fields, or different fields may be required versus not. So you can set up different rule sets here for each of those situations and just specify that when you use your validator. For our purposes, I'm just going to create one default validation rule set. I will set that as the default on each of these types. So then once we have a rule set set up, we need to select the members we'll be validating. So I'm just going to select those top three members here, because obviously the others are just for our internal use only. And then on the bottom type, I'm going to do the same. I'm just going to select that main property. So now we have the targets of what we're going to be validating. So for our example here, I'm going to say that the name is a required field. So I'm going to add a validator, and I'm going to say a not null validator. So that means that this must be present in the request for it to be a valid request. Now the other note is, since this is a string, an empty string is not considered null. So if I want it to be more than one character, I'm going to add a string length validator and say that it's got to be at least 1 character long minimum, and I'm going to say that it can be as long as we want. So I'm going to ignore the top, the upper bound, and we're going to say the lower bound is 1. And so basically then for my name to be valid on any request, it has to be present and at least 1 character. So my value, again, I'm going to say that's required, so I'm going to add a not null, and then I want to say this is must be an integer. So to validate that, we can say I'm going to add a type conversion, which basically says that this input value must be convertible to the type that I give it. So I'm going to go ahead and say int32. One thing to note about these two here, we have 2 validators for each type. Being that we did not put them inside of an OR, by default they will be ANDed together. So to be a valid field, both conditions must be met. If we wanted something that's either or, like what we're going to do with the other reference to the inner class, we would go ahead and set up our first validator to be an OR composite. And so within that, I can say, basically, as long as any one of the validators are true, we're valid. I'm going to say for this one, we want it to either be present and a valid object, or null, meaning not present, is also valid. So I'm going to add a not null validator, and I'm going to flip the negated to true, which means that to be valid, it can be null, or we're going to add an object validator. So this tells the framework to create a validator for this object type and run it. So in this case, to be from the myself property to be valid, it must either be null or a valid object of that type. That's what this rule set basically says. So in the lower one, I'm just going to make it simple. Unique ID I know is a GUID, so I'm going to add in a type conversion, and I'm going to say it must be convertible to a type of GUID. I'm going to save our configuration. That basically is complete to some degree. There's a few little things we will need to flip here because we are using the unofficial version rebuilt for .NET Core. The public key token is not going to be the same. So we need to go ahead and flip that over to null, because I know that that public key token is null here. So that way everything still properly loads up using the .NET Core Enterprise Library libraries. So that completes the configuration piece. Now we need to load that configuration and tell our validators to use that configuration. So let's go ahead and pull in some code. So through the magic of copy paste, we have our code. I'm just going to go ahead and fix our usings that we'll need to have using the automated pieces that are going to just detect the way we can fix things there. I think there's one more that's not automatically detecting. We need a using link. That should fix that one. All right, so this code here is basically going to say I'm going to open the configuration. Locally, I know this is the path where I'm building. That's where the configuration is going to be. In Azure, when we're running in release mode, Azure by default is going to store everything in D, home, site, www root. So I'm going to go ahead and indicate that as my path. And to make sure we do get up to Azure when we go to deploy, I'm going to say, instead of do not copy, copy always, so that when this gets deployed, that validation config will make it up as well. So then, once we have our configuration loaded, we tell the validation factory that this is our default configuration. Then we use the factory to create a validator for our type, and we use the result to do the actual data validation. So this test object is going to be a result for validation results. And so part of that includes a flag that says this is valid or is, it's true or false. So if it's not valid, we're going to return a bad object result, just selecting back a few items off of there. As opposed to returning the entirety of that object, you theoretically could. If we don't, we're going to return an OK result. And as I just realized, we needed to change this from dynamic to var to make sure we eliminate the error we were seeing down here. That wasn't actually related to usings. All right. So now we have a function that will automatically do our validation of our input objects. So to test this, I'm going to go ahead and do this a run locally. And that'll spin up the hosted instance locally, and we can do some testing using Postman. So go ahead and get this started and give that a run. So as you can see, we have the runtime here spinning up. And you can actually watch any logs that get logged directly on the screen here, if needed, for debugging. So this is the Azure Function Runtime for version 2, and it's starting up now. As soon as that's done, have a request ready in Postman here. And this is a valid request, so it has a valid name, which is present. It has a value, which is convertible to integer. And it has the internal object, which has a GUID as the value. So we are spun up now, and if you didn't already have it, this would be your endpoint that you'd be using for test, which is already over here populated, but that's where you get your URL you need to test with locally. I'm going to go ahead and give this a send. Now the first request will take a little while because it's going to be doing some runtime loading of those various validation and type libraries. Those get loaded at runtime, so it does take a little longer on the first spin up. Give that another second here, and we should get our response back, which should just be a status 200 since it's a successful request. We aren't doing anything else with it just yet. And there's our OK status response at the bottom. So now if we went ahead and we removed we turn this field, which we know should be an integer, into non-integer, and we rerun, we should get back an error. And as I mentioned, we were selecting just a partial of that error back. So these messages here, this is the default message coming out of the validation block and can be customized as needed. So let's say we have multiples. Here's another advantage of the enterprise library block, is you're going to get everything that fails validation. So it's not going to just stop first at saying that my name can't be null. It's going to give you everything that's failing at that time. So in this case, we've nulled out my name, which means it also doesn't fall in the string length. And we still have an invalid my value. So we get all three of our validation issues back. And also, just to show the inner validator is still working, we'll get an all validators failed for that key of myself. Now that is kind of hidden on that validation result object. We're obscuring that away, but it's possible either through adding a message to it or actually pulling the whole object back, that you would see everything inside that object validator that fails as well. And we're back to success. So that's the validation block. Next, we're going to go ahead and take a look at using the exception handling block to properly obscure away exceptions or handle them and log them in certain ways. So let me go ahead and stop our runtime here, and we'll need to get some new a new package out of NuGet to handle this, which will be we're going to kind of do two at once. So I'm going to grab the exception handling along with the transient fault. Being that those are both kind of related to handling exceptions in certain ways, I think it makes sense to go ahead and take a look at both of those at the same time. So I'm going to pull both of those for us. Okay, now we have our enterprise library references for those as well. I'm going to go ahead and create us a new configuration file specific for exception handling. I'm just going to call this exception handling config. And it's kind of like being able to put your try-catch blocks directly into a config file instead of having to recode them every time. So it kind of makes us able to handle exceptions consistently across the board in all our applications the same way by easily just referencing a config file. Again, we can use the enterprise library configuration tool. We'll just have to keep in mind, as before, that this is using the unofficial release, so we'll just have to edit that config manually to remove the public key token that's incorrect. So I'm going to go ahead and add in the exception handling block for us. Now, by default, on this one, we actually get a policy out the gate. We can have multiple policies that dictate how to handle exceptions. And by default, it's going to have something for all exceptions. So I'd like to go ahead and just add a separate one here. We'll handle the XML exceptions separately, for example. As with your try-catch blocks, you want the more specific exceptions up top. So I'm going to say move up. So XML exception at top, all exceptions on the bottom below that. There are a couple of options on how to handle it after it's done. For this, I'm going to do throwing a new exception on both of these. And the reason I'm going to throw a new exception is I want to add a handler that replaces that exception. So when we do a replacement handler, what that does is it takes the exception we have and basically replaces it with what we tell it here, along with the message we give it here. And so now that we have these replace handlers, I'm going to just tell it that I want to replace these exceptions no matter what type. I'm just going to replace it with type generic exception. And then I'm going to give each one, save a little time here, copy paste this down here. And I'm going to go ahead and give each one their own specific message. So here I'll say something like enterprise library XML configuration error. And here I'll just say service call error. I'll go ahead and save these. And just like before, we will need to go ahead and, like I said, remove the public key token that's invalid for this version of the library. Now, the other thing I will do here is I have created a custom handler that is capable of logging directly into App Insights. So I'm going to go ahead and copy paste the configuration in that'll make that happen. And as I mentioned before, these are done in order. So because I want to log the actual exception, not the one that gets, not the one that replaced one, I want to log the actual exception. I'm going to put the App Insights handler first, and then I'm going to allow the replace handler to go second. That way, what gets logged using App Insights is the actual exception, and then what gets replaced and returned back as the generic message. So to be able to make sure that type is available, I'm going to go ahead and reference it here, and then I'll just show you very quickly the code behind it. It's fairly simple, the implementation of it. As I mentioned, the enterprise library is pretty easy to extend as needed. So let me just go ahead and pull up the code. As you can see, constructor is very simple, just takes in the App Insights key, and then creates the App Insights telemetry client. And then when it's the handle exception method is what actually extends the enterprise library. So it accepts in an exception and a handling ID, instance ID. So what will happen is this exception coming in is what we're going to log, and then what we return is what makes it down to the next handler. So for example, if we were coding the replace one, what you'd see is that instead of returning the exception that came in, we'd return a replaced exception. Here I'm saying that if I want to treat it as handled, I'm not going to return an exception, otherwise I'm returning the exception that came in. So it's pretty simple what we're doing here. And so that's what I've just referenced over here. So now that we have our configuration ready, can't forget I need to make sure that it does get copied for when we go test it in Azure. So copy always on that as our build action. Now that we have our configuration set up, we need to go ahead and create the logic that will do this. So what I'm going to do is I'm going to just get rid of this OK result. So obviously if we have a bad validation, we're not going to move on any further. But beyond that, we're going to go ahead and load up the exception settings, much like a very similar manner to the validation one. And we're going to go ahead and make sure we use any usings that we need to add. So again, we're going to load it out of the local path here. We also are leaving this in place so when it moves up to Azure, it should be able to load without any issue as well. All right, so now what we need to do is going to kind of use the transient fault block and the exception block at the same time. So just 1 second, I'll copy paste our code in. And make sure we get any usings in place that we need for the transient fault block. So what I've done here is just to kind of get us a demo going, I've created a custom strategy, which I've aptly named the custom really dumb detection strategy. And all that is it basically says, is the type of exception a timeout exception? And so this shows you kind of the simplicity of how you would extend the transient fault handling block. Basically by implementing this interface, the iTransient error detection strategy, we basically have to create a method that says is transient, accepts in an exception, and then returns a Boolean of true or false. So it's pretty easy. You can do any level of processing you need against the exception, from being as simple as to what type it is to detecting certain codes within an exception, like a SQL exception, to tell whether it's something that could be transient or not using the codes within a SQL exception. So this can be as complex or as simple as you need, but in our case here, just to get things moving, I created us a pretty simple exception detection strategy. So what we're going to do is we create the retry policy, and we're basically going to say we're using this detection strategy and then we're going to give it basically a retry count. So this tells it how many times we want to retry. There are some other things we can give it. We can give it the interval between the retries, and then we can make it an initial interval is different than the actual incremental interval. And then also we can create back off scenarios where it starts very quickly and starts moving to a much longer time in between retries. So it's pretty flexible out of the box. And if you need additional policies, you can actually implement a new retry policy altogether, which will give you that additional flexibility, being able to dictate your own kind of amount of time in between retries. So once we have our retry policy set up, we're going to use the exception handling settings. We're going to build the exception manager out of that. And then we're going to basically call the process method. And that's a generic method where we can tell it what type we're getting. So in this case, we want to return iActionResult because that's what an Azure function is going to return. And then we pass in a Lambda function. That Lambda function is what's going to be executed using that particular exception manager policy. And the policy comes after the Lambda function, so it's kind of hard to read, but this here dictates our policy name that we're going to be using. So inside of the exception manager, we're going to use the transient fault block so that our retries can happen before we detect the original exception. So for example, if we have something that is a transient fault, we want it to go through those 3 retries before it gets processed as a standard exception using our handling settings. So that's why we put that inside of here. And the same, kind of similarly, it uses execute action. And we're going to give it it's a generic method. We're giving it the type iActionResult, and we're passing in inside of there the Lambda function we want to use and process there. So pretty simple. I'm just using the data inputs to know when we want to cause an exception and when we don't. And when we don't, we'll just pass back a quick little message here. And when we do, we can throw those particular exceptions, and we'll be able to see how often they are occurring. So just to kind of help out with that, I'll go ahead and throw in a log here. So we'll be able to watch this in the .NET runtime and actually tell how many times each one of these, how many times that is running. And we'll go ahead and do the same down here so that we know we can show how many times each of these is running. Now that we have that ready, I'm going to go ahead and start our application. So we'll go ahead and give that a test. As before, here's our .NET runtime. It is opening up, loading. There's your endpoint again, as mentioned before. So we currently have no exceptions coming through. I'm just going to run it to make sure that we get all the way through and nothing unexpected happens for us here. All right, and as I expected, we got 200 OK. We have no errors, and then the name returned. So I'm going to go ahead and force some exceptions. First, I'm going to do the cause XML exception. I'm going to format my JSON properly. Let's go ahead and give that a run. What should happen then is we get one exception, and of course we're debugging, so it is going to come up. So there's our fake XML exception being thrown. Go ahead and hit play, and then obviously we can see here in the .NET runtime that it did encounter that exception, and the message that actually was put onto it is Enterprise Library XML configuration error. So that's expected. That's coming from our exception handling policy, and it's replacing that XML exception with our message that we expected. And on the other side, we'll go ahead and just do a regular cause exception, which will cause that timeout exception, which, as you remember, we've configured to be transient. So it is going to hopefully try for us 3 times when we run this before it actually returns back an error. Now let's take a look at our .NET. We have running generic cause exception is occurring several times here. It's done it once and it came across an exception. So then, as our retry block says, we are retrying 3 times. So we have those following 3 retries. And at the end, since it is not an XML exception, is going to be caught and then replaced properly with this service call error, which is our generic method that we dictated in policy. So the next thing I'd like to do then is, since we did also have this set up to use the custom app insights handler, what should happen as well is, because we put that on the generic exception level, the XML exceptions will not get logged to the app insights. However, the other exception here, our service call error, which originally is a timeout exception, should indeed be logged. So I'm going to stop here, and I'm going to pull up our app insights to take a look and make sure that that made it in. So I'm going to go ahead and pull up the Azure portal and then go into the app insights once we come up there. So I'm just going to click on app insights, pull up our subscription and go into the analytics. That'll show us, be able to show us exactly specific instances that get logged with App Insights. So I'm just going to pull exceptions. Last 24 hours should do it. Okay, and as you can see here, we have the system timeout exception. It is logged once because the retries happened first inside. So we only see the one item actually end up logged. So this will be the actual details, the original exception, which is that system timeout exception, which is, we put that message, the new fake exception thrown here. So as opposed to having the replaced general exception be logged, which is what App Insights would do on its own, we just have the timeout exception being logged. So the last enterprise library block I want to work with today is the data block, which gives you kind of a way of being able to access your data layer. So I'm going to go ahead and reference the enterprise library data net core. Let that do its installation. And then I'm not going to use the enterprise library configuration tool for this. It's pretty simple. It's basically a matter of creating a config file that's got your connection string in it. So I'm going to go ahead and create a new connection, or a new config file. Just call it data.config. And I'm going to go ahead and pull in standard configuration file here. So as you can see, basically it's here we indicate what the default database is. That's only required if you're going to use the data library and just say, you know, create default database. Otherwise, you can create the database and give it the name of the connection string you desire to use. I'm going to go ahead and save this. Should already be ready to go with the proper removal of the public key token, so we shouldn't need to make any changes here since I already had that prepared and ready. As with the others, I'm going to make sure that we do a copy so that when we deploy to Azure, everything should be dandy. And so then the last thing we need to do is go ahead and replace this here with some code that will make a database connection. So again, through the magic of pre-created code, go ahead and replace this here. You may have some usings to fix. I think that should take care of it. So basically what we do here now is we have I've left the enterprise library exception handler and transient fault block in place, but I've added in the use of the database provider factory. And so we just provide it as usual, the name of the configuration file, and I've done as with all the others. The debug will run our local path, and the release will run the Azure path. And then, as I mentioned, we do a create default, which gets us that default database instance. Just going to run a quick query against a table that's already set up there. I'm going to use the ID that gets passed in as part of the inputs, that unique ID that we had passed in. So I'm just going to basically provide a SQL string using the parameter format, and then you do the add-in parameter to provide that value. We'll do an execute reader. If we don't get a result back, we'll say this is not found in the database. If we do get the result, we're going to pass back what's actually found in the database on our result. And that's all going to be done within those exception handling blocks. So now we have all of our blocks combined together, used all at once. So I'm going to go ahead and kick this off so we can show that we're able to pull back information out of the database using the data block. So let me take out the cause exception because we already know that works. And we'll go ahead and give this a run using a value that should be in the database. Again, first time load is going to have a lot of runtime loading happening within the enterprise block. So it just takes a little extra time the first time. Once it's awake, it's pretty quick on the load. So as you can see here, the original name and value is stored in the database. It was found, so if I just change this to something I know is not in the database and then run it, I should get that other message. And of course, I managed to pick the one that is there. Let's change it again. No ID found in the database, so it provides that ID back. So as you can see, we are able to contact a SQL server through Azure using this framework as well. So the last thing to show you on this is to actually deploy into Azure and run this function in Azure. So it's pretty simple using the tools provided within Visual Studio. We just right-click and we say Publish. And the Publish window now will provide us all that we need to be able to set up our resources in Azure and actually copy up. I will say that since this is kind of in beta, I did notice some issues with doing this. So hopefully this will work for us first time. So I'm just going to say I want to create a new Azure app service that I am publishing to, and I'm going to go ahead and click Publish. And then that should load up my Azure account. It's going to automatically name it based on date and time. And I'm just going to go ahead and use that and all the defaults that have been provided. So I'm going to go ahead and click Create, and we'll see how well this goes. And after this happens, this only has to happen the first time when you're creating the Azure function. After that, the publish should already have your information, and you should be able to just click Publish, and it'll be a single click, and it should just take care of moving up into the existing Azure function you already have. As you might expect with beta, we seem to have a problem here. So I'm going to click Cancel. I believe this should have actually created. So let me see if we can get this published then. So now, since it technically did create everything, it just failed to upload. What you can do is go back, and then on your Azure App Service, do Select Existing and Publish. And we'll go in and we'll select this function app. And that is what we're going to deploy to, and click OK. And we'll watch the output here just to make sure that everything publishes OK. So this may happen to you occasionally, update function versions on Azure. And then we're going to go ahead and say, yes, we want to do that. I think that's what's missing out of the automated publishing, and why it's not working at first is because it actually has to set that function variable. And I don't believe they're doing that in that initial that initial window, I think. So once that was done, as you can see now, publish completed. So we can go over to our Azure subscription, open the function apps, and we should be able to see and call this function directly inline in the Azure portal. So as you can see, we have the antlib demo function is sitting here ready to go. So I'm going to go ahead and click on it, and we should be able to give it a test directly in line here. The other thing we can get out of the portal here is, since I did set this as authorized functions, you do have to have the function key on the query string when calling it remotely. So obviously here it doesn't matter in this front end. I'm going to go ahead and pull open the test, and then just pull over our valid query or valid JSON out of Postman and paste it on in here so we can do the full test. So let's go ahead and do a run. So apparently the first time it doesn't work, and then after that it's got everything loaded up. There were some issues with it loading first time, and after that it seems to have got everything loaded up properly. So as you can see here, we get the same basic message coming out, no ID found in the database, based on this request here. I believe we need to just flip this end one back to a 9, and I think that should be one that's actually valid in the database. Yep, there we go. So ID found. So everything is working in Azure as well. So if you want to be able to make a call to this directly from Postman, then you need to actually make sure that it is properly using the keys. So I'll show you now where you can get into keys to be able to load that up. So we'll need to show this value and pull out this key and copy it. And that'll be what we need to put on the actual query string when calling from Postman. The other way you can get at that actually is to go into this get function URL. That'll actually already contain the key for you, and you can just do a full copy of that URL. So now let's go over to Postman, and we can paste it in place and do a request from here, direct into Azure. So now, as you can see, we are actually, instead of testing locally using this code, we are getting that return out of Azure. So if you remove this code, it's not going to let you make those calls, since it is set up as that authorization is required. So all you need to make sure of is that you have your key on that correctly. So now I hope this has given you a good background on a little bit of Azure Functions, a little bit on Enterprise Library, and how you can use them together to create enterprise-grade solutions using Azure Functions.